literal equations, common formulas, all right? So we want to solve each literal equation or formula for the indicated variable, and many of these formulas are things you would see in math and science or science all the time, all right? So you may not see it with capital letters or lowercase letters, but let me say something about that. For instance, this first problem here, D equals RT. The D, the R, and the T are all capital. Solve for capital R. You cannot change it to lowercase d in the middle of the problem. A big uppercase D and a lowercase d are different variables in math and science. There are several examples of equations that use uppercase letter and lowercase letter of the same letter. Okay? So just be sure that you are aware of that. So if you're in my class and I give you a lowercase d and you change it to a capital D, I'm going to count off because it is a different variable. All right, so here, solve for R. Well, I want to get R by itself. Well, R is times T. How do I undo times T? There's nothing added or subtracted, so I just do what? I'm not going to mess with the original. I'm going to say D equals RT, and I'm going to get rid of the T. So divide both sides by T. So that divides out. So capital D divided by capital T equals capital R, and there R is. And it's okay that R is on that side. If your teacher makes you write it this way, then by all means you do that because you're in their class. I am not going to make my class do that. That's the same thing. If there's an equation here, if there's an equal, I don't know what I just did. All right. I went too low there. If there's an, hang on. If there's an equals here, then it doesn't matter what side the R or the D over T is on. It's equal. It's the same thing, right? So I would say that was technical difficulties, but that was user error there, okay? That was me. A equals 1/2 BH for B, right? A equals 1/2 B times H and solve for B. So on this one, I have a fraction and I have only one denominator. So what's my LCD? My LCD is 2, all right? I solve every equation with a fraction in it the same way for all my algebra classes at every level. And then as you, the student, becomes familiar with, oh, I cannot do that step on this one. I can just go straight to this step and you can skip things and that's fine. That's fine. But I'm not going to work fraction problems 17 different ways and confuse you. I'm going to work them all the same way. And then as you begin to see patterns emerge, you can say, hey, Mr. Guest, can I just go straight to this step on this problem? Yes, you can. All right, sounds good. So here I'm going to multiply everything on both sides. 2 times the A equals 2 times the 1/2 BH. Okay? Now be careful when you use a lowercase b because lowercase b and 6 can look a lot alike. Okay? So make sure you exaggerate your b in the corner of it at the bottom so you don't confuse it with a 6 because some of you write as messy as me or even worse. Poor you. Okay? So I don't like to use b's. I don't like to use lowercase a because we mix it up with q's and 9s. Okay? Or Q even, mix it up with 9. So if you use a Q, put a tail on it. That way it doesn't look like a 9. All right? So, and we'll talk about more letters as we go through here and things I do to help myself remember those things and keep them separate. So 2A equals over here. This 2 is over 1. They divide out. So that those 2's are gone. They become 1s. I'm left with BH. Now that looks a whole lot like the one I just did, the D equals RT. I'm trying to get B by itself, so what do? I divide by H. And I'm going to come over here where I have some more space. I have 2 capital A over H equals B, little h and little b. But the A is capital, and that matters. Don't change it. If you have little a, 9, sometimes you do that and you don't know, all right? Don't use, if you do little a, I like to curl it or draw it this way, all right? So that I know it's not a 9, okay? If I use a T, a lowercase t, I curl the bottom versus a plus. If I do this, I don't know if that's a plus or a T. So I curl my T's and I don't curl my pluses. You with me? If I use S, see sometimes I write an S and a 5. You can't tell the difference sometimes, okay? So if I do an S in a formula, I do what I call capping the ends. That is the letter S, okay? If I use, see if there's something else, B's, 9's, Q. If I do a Q, like I said, that versus Q, right? That's 9, that's Q. Then I don't ever wonder what's what, okay? Capping my S's, curling my T's. I don't like to use A's and B's. I will, but I don't like to use it, Q's. Z and 2, that's the other one. All right, so 2 and Z. Well, I put a line through my Z. Then I never have to doubt, is that a 2 or a Z? I suggest you do the same if you don't. If you write really neat and you go, oh, I got this pretty little curly Q and that's my Z. I mean, if you can tell all that stuff, that's fine. All right? But I can't tell you in my 3 decades of tutoring and teaching math how many times I've had a student tell me that Z squared was 4 because they write like I do and got confused. Okay? So put a line through your Z's and don't put a line through your 2's and you're good. All right? So now that you've had a lesson in guessed hieroglyphics, let's keep moving. C equals 2 pi r, solve for r. So again, everything is multiplied by r right here. So what we're going to do is we're going to say C equals 2 pi r. We're going to divide both sides by 2 pi. All right? And remember, pi is like 3.14, and I don't mean the kind of pie you eat, which would be really good. All right? So C, so this is going to be C over 2 pi equals lowercase r, and that's a capital C. And C's are shaped the same way. When there's nothing beside the C, it's hard to tell if it's capital or not. But if you had if I had 2C, that's a capital C, and 2C, that's a little c. Right? If something's written beside it, it's easier to tell if it's, things like C or P that are shaped the same way, lowercase and uppercase. All right? So C over 2 pi equals R. And you're like, Mr. Guess, you're talking about all these details and stuff, and we're doing all this crazy stuff with letters. I know, but details matter. That's why you take algebra, to be well-rounded, is to pay attention to detail. It makes you better at everything you do in life if you can pay attention to those details. It doesn't matter what you do in life, you're better at it if you can pay attention to detail. So when I talk about these details, yeah, it helps you with math, but it helps you with every aspect of your life. I don't care if you play baseball. I don't care if you're the manager of Walmart. I don't care if you run a Fortune 500 company and you're the CEO. Details matter. So E equals MC squared. Solve for M. Solve for M. Well, E equals MC squared. I want to get M by itself, so divide by C squared. So those divide out, and I get E over C squared equals M. And there it is. E over C squared equals M. And then A equals P, a capital P, right? Because it's written beside something else. If it was written like that, that would be a lowercase p, right? But you can tell here it's all on the same level, so that's a capital P there. That's a capital P. So A equals P plus PRT. Solve for little r, all right? So the first thing I need to do, here's my term I need to isolate, and I got to get rid of this P right here first. That P is added, not this plus goes with this term over here. So this is an understood plus there. So because of that, how do I get rid of that P? Well, if I talk about A equals P plus PRT, I need to subtract P from both sides. Okay, that cancels over there, and I get A minus P equals PRT. And then I want to get little r by itself. What's the relationship between the P, the R, and the T? They're all being multiplied. How do I undo multiply? I divide. So divide by PT. And don't do this, because then you just made the P little, right? Don't make it little p, it's big P. So P, T. That divides out, and let me come over here where I have some more space. I get A minus P over P, T equals little r. All right? So there's my solution there for little r. So I had to move the P, subtract it from both sides first, and then I had to divide by PT, that's just like a number. It's just we don't know what P times T is. It could be 4, it could be 37, it could be 15.5632. It could be 0.0325. We don't know. All right? Now solve A equals P plus PRT for P. This one's a little more complicated because when we solve for little r, there was only the little r in this term, right? So we only had to isolate that term. But here, P is in two different terms. If you're solving for something that's in multiple terms, you need to get everything with that variable in it on one side of your equation and everything else on the other, and that's already the case here. If it wasn't, I'd have to move some stuff around. And then we do everybody's favorite thing, we factor. It's a GCF, though. What is the greatest common factor of these two terms? So we're going to say A equals P plus PRT. Factor out the P here. How do I factor it out? Well, A equals capital P. That's a terrible equals. It's kind of all on my A there. P, and then I'm left with 1 plus RT. A equals P times 1 plus RT. And again, 1 plus RT in parentheses. If we know what R and T are, we multiply them together and add them to 1. We get a number. It's like 2. So that's like 2p or 8p or 1.57p. How do I get p by itself? Well, I divide by the thing multiplied by it. And my plus sign there kind of went crazy, so let me go fix that. As I picked my pen up, it ran away. All right, so this is going to be 1 plus RT. I'm going to put it in parentheses there, but only because I did over here. Really, if it's the only thing down there, I don't have to have those, okay? So I'm going to divide these, except I need to go back, user error again, right? Divide those out and get P equals A. Since this is the only thing down there, I'm not going to put the parentheses, all right? However, if you do this, then you must have the parentheses. If you do this, then you really just wrote this, because that's A over 1, which is A. All right, so that's what you just did if you did that. It's I don't care what it looks like. I don't care the level it's on. I don't care what anybody says. They're not correct. If you don't put parentheses around that, then it's A over 1 and then plus RT. It just is. That's what math is. Math is not ambiguous. So if you write slanted fractions, don't ever again. It's just the best way I can say it, okay? If you write slanted fractions, just don't ever again. And if you're a teacher watching this and you use slanted fractions, shame on you. Because what you're doing is you're showing your students something that's, you know the difference of when it's okay and when it's not, how to do it correctly and how to do it not most likely. But you're confusing the mess out of your students because it looks like the rules of fractions are changing all the time. Write horizontal fractions and everything in the top and the top and everything in the bottom and the bottom. If you write horizontal of slanted fractions, just don't. Just don't. Just don't. All right, so there it is, A over 1. And is there any doubt in what I wrote right here as to what the numerator of the top is and what the denominator of the bottom is? There's no doubt. There is none whatsoever. That's why I write horizontal fractions every time. Every single time. And I also don't do this. What's wrong with that? I don't know what's really in the top and the bottom. I need my fraction line to fully extend over and under everything. So always do that. It's a detail. Again, it's in the details. But details matter. Details matter. S equals C over 1 minus R. Now that's a capital S and a capital C and a lowercase r. And solve for little r. Now this one's kind of crazy. Little r is in the denominator and it's multiple terms here. All right, and I got an S, a capital S, so I'm going to cap the ends of my S like I talked about earlier because I'm going to use it. I don't want to think it's a 5. So my LCD here, my LCD is 1 minus R. My LCD is 1 minus R. So what I'm going to do is I'm going to multiply it by 1 minus R equals C over 1 minus R. I'm going to multiply it by 1 minus R. Now, what I typically do, notice I didn't write my LCD in the front. You know, earlier I wrote like 2 times A and 2 times whatever. When my LCD is just a number, I put it on the left and the front. When it's a parenthesis, because we're going to do something here like distribute, it's easier to see when it's on the right side. So when it's multiple terms for my LCD or multiple parentheses, I put it on the right. Okay? So then here, this is over 1, and these divide out. So I'm left with just C here. And over here, because I'm solving for R, I don't want 1 minus R in parentheses. I want to distribute. So I get S times 1 is S minus S R. Right? S times 1 is S, and S times negative R is minus SR. And I'm solving for R. I'm solving for R. So look, I don't want this term to be negative. You can leave it over here if you want to. I don't want it to be negative. It is going to give me an extra step here. This is one of those 6 one side, half dozen in the other things where it doesn't matter because a half dozen is 6, right? A 6 on one side, half dozen on the other. That just means it doesn't really matter. So I'm going to add SR to both sides. So I'm going to do an extra step here. That cancels. S equals SR plus C, and then I'm going to subtract C from both sides. And that gives me S minus C equals SR. And then I'm going to divide both sides by S. That divides out. And I come up here and I'm going to say, okay, this is S minus C over S. I'm still capping those in so I don't think they're 5s. Equals R. Can I cross these out? No. How many terms do I have here? 2 terms. If I have 2 terms, I can never cross out one term in a string of terms. And when I say string of terms, I mean 2 or more terms. 2 terms, 3 terms, 4 terms, 5 terms. If I have a string of terms all added, subtracted together, I can never cross one term out of that with something in the denominator or numerator, top or bottom. Okay? So this is the final answer here. So again, I wanted to show you this one. This one is sort of, you're getting kind of beyond the basics here. This is not just a basic literal equation, but I just kind of put all the literal equations together here that were in the book I'm currently using, and maybe I added a couple more. So, but I wanted to kind of give you a kind of a range here of these things so you could see them. 1 over r equals 1 over r sub 1 plus 1 over r sub 2. Okay? This one is borrowed from physics here. All right? So you have a overall resistance and a resistance for 1 and a resistance for 2. Okay, and you can even have more. All right. So we want to solve for R1, but when I look at this, I have 3 different things, and I have no idea if they have anything in common. One could be 10, one could be 9, and one could be 7, and they don't have anything in common. So my LCD has an R, an R1, and an R2. So I like to draw a line and say, okay, what would that look like? It'd be R, R1, R2, all multiplied together. I don't know what the numbers are, so I can't say, well, it's 37 or 630 or whatever. It's just R times R1 times R2. So I'm going to multiply R, R1, R2 times 1 over R equals R, R1, R2, 1 over R1. So what I'm doing every time I have a fraction with an equation, every time, I multiply everything on both sides. So plus R, R1, and R2, 1 over R2. I multiply everything. And what I'm really doing here is I'm taking this and I'm distributing my LCD, right? I'm distributing to both terms, right? This is the first part and this is the second part of that distribution. I just go straight to the distribution and say, look, if I have an LCD, I've got to multiply every term on both sides by the LCD. And what's that going to do? Eliminate my fractions. That's a glory hallelujah moment right there. Okay? Glory hallelujah. I'm eliminating my fractions. That should make me really happy. So I'm going to change colors here. This is going to be over 1 for all 3 of these. And then the R's divide out, and I'm left with R1, R2 equals. Over here, the R1 divides out, and I'm left with R2 plus the R2's divide out, and I'm left with what? R1. What am I solving for? Well, look, it really didn't matter what I was solving for. I was going to eliminate my fractions anyway. But I'm looking back, I'm solving for R1. That means I need to get all my terms with R1 on one side of the equation. So R1 is already over here, so let's take this term and move it to this side. So I'm going to subtract R1 from both sides. That cancels, and I get, look, are these like terms? No, they're not like terms. So say R1, R2 minus R, R1 equals R, R2. Right, so that term comes down, and then just this term and this term. So then, what's next? Well, look, I have 2 terms with the same thing in it. They're on the same side, so now remember I factor. R1 times R2 minus R equals R, R2. And then now, finally, I have R1 times something. That's just a number. It just looks funny because it's 2 variables subtracted. We still divide by that because that's what we do. R1 times all that stuff. So we divide by R2 minus R. I'm not going to put it in parentheses because it's the only thing down there. That's R2 minus R. So that divides out with that. And I'm going to, again, come up here in some, I'm going to come over here in some empty space. And I'm going to say this is going to be R1 over nothing because I'm solving for R1. So let me kind of fix this. R1 equals what? R2 over R2 minus R. Now, if we keep going, what can I do? Can I go through here and just ask this question? Can I go through and cross those out and cross those out? You better say no, because why? How many terms are down here? 2. That's a string of terms. I said 2 or more. I cannot cross out one term with something up here. That cannot happen. That's a no-no. All right? So let's get rid of all this red here. This is actually your final answer right there. Okay? That is actually your final answer. R1 equals R times R2 over R2 minus R. All right? So I hope this helps you with literal equations.